I'm Doug Campbell. I'm a site reliability engineer at Grubhub. And today I'm going to be talking about self-service chaos engineering and how we fit Gremlin or any chaos engineering toolkit into a DevOps and SRE culture. So before I really get into my slides, I'll do a little PR for Grubhub and give some context on why reliability matters to us. For anyone that doesn't know, Grubhub is a food ordering and delivery platform with the goal of connecting diners to local restaurants. As of August, when I grabbed these stats, we had over 28 million active diners, 300,000 restaurants on our platform, and average around 650,000 orders a day. An outage or a problem can easily ruin someone's day, from the drivers that can't get any orders to make money, to the restaurants that have to deal with angry customers if an order is wrong, to the parents with grumpy kids waiting on food that shows up an hour and a half late. I'm sure almost everyone here that orders food often has experienced some issue on whatever platform it is you use and knows how frustrating it can be, amplified by the fact that you're hungry and angry. So engineering at Grubhub, and as a whole, not just SRE, is relentlessly focused on minimizing what can go wrong and building fault-tolerant distributed systems to make sure our diners, drivers, and restaurants have a positive experience. I've been an SRE at Grubhub for 2.5 years now out of Chicago. First, I worked with our delivery logistics vertical, which helped make sure everything from like order routing to driver payments went smoothly. And now I'm on the SRE team that owns our CI/CD tools and workflows, which includes things like chaos engineering and how we can leverage chaos to make our systems more stable and reliable. So in the title of my talk, I mentioned self-service. And before I get into the details, I want to explain what I mean by self-service engineering. In a lot of ways, I just mean automation, but specifically automation that is made to be used by all engineers, not just operations or SRE. It's basically what we hear about as like a DevOps culture, but DevOps is kind of a loaded term, so I like to avoid it. It's not just automating infrastructure creation, but it's making those tools usable and approachable to the larger engineering organization. I like the analogy of a vending machine. I want any engineer to be able to go to the vending machine and press a button and get an S3 bucket or a deployment or a chaos test and get what they need without ever having to approach SRE or some special team. I've worked at a few places now that really focus on this self-service culture, and it seems to come with a lot of organizational benefits. It's not just about increasing velocity, but it helps reduce blockages caused by operations. It frees SRE to do more impactful project work, like chaos engineering. It helps reduce those knowledge pockets or knowledge silos, since no single team has to do all the work or has all of the knowledge. And it helps create like a culture of trust, where engineers are empowered to do what they need, where we in SRE trust them to make smart decisions, and the devs trust that there are appropriate guardrails in place to maintain system stability. Our desire to maintain this culture of engineers being able to self-service really drove how we implemented chaos engineering. So why did we want to implement chaos engineering? I talked about why reliability is important to us, but why did we think chaos would help? So we had some things we were proud of. We had what we felt was good observability. All of our services had SLOs defined. We had lots of custom application metrics, and developers were on call and they supported their own applications. We felt pretty confident in our abilities to alert on and respond to problems. But what we didn't have was reproducibility of problems, like this infrastructure level fault injection to replicate problems, or a way to experiment at all. And so we didn't feel confident in our ability to cause, reproduce, or find new problems. We did have some hacky ways of introducing failures, but it usually required an SRE to manually mess with individual hosts, like add IP table rules or fake load or manually kill nodes. It was unstructured, hard to use and reproduce, and it didn't scale at all. And only a few people really had the power to even run it. It's something we really only did after emergencies and not before. It gave us no way to experiment with failure. And so we felt like with some level of infrastructure fault injection, we could validate our SLOs before real problems validated them for us. And we wanted this platform for experimentation to help us uncover problems we hadn't really even thought of yet. So insert chaos engineering and the idea that through breaking things, we can learn a lot about how our systems work and use that knowledge to make them better. Our infrastructure, like most organizations, is constantly growing in complexity. And with that, our list of assumptions on how a service behaves grows. So here are questions that we or engineers at Grubhub found ourselves asking often. Does this load shedding work the way I hope it does? Does this timeout actually stop a heavy operation before it can cause downstream problems? Does my custom metric tick on a weird scenario? Does a message get processed again if a Cassandra node goes down? What's the consequences of losing an availability zone? Or what about an entire region? And like I said, we had some ways of testing these problems, but no easy way that we could put in the hands of our developers and give them room to experiment. So implementing a chaos engineering tool could help us answer all these questions and uncover the ones that aren't listed. And we really believe that ultimately developers know their services best. And we knew that whatever tool we used, we would need to put in the hands of our developers to get the best results. We also knew that any tool we introduced would need to be integrated into our existing workflows and fit into like the self-service culture. We really wanted to give each engineering team the power to experiment. Just throwing a new tool at developers makes it one more thing they need to learn. But if we could fit it into our existing workflows, we believe we could really increase adoption with it. And spoiler, Gremlin is the tool we ended up picking, just kind of to its ease of use and compatibility with our infrastructure and an API so that we could fit it into our existing workflows. So after we did a quick POC, settled on our tools, here's how we rolled it out on a technical level. First, we added Gremlin to all of our services in pre-prod. We didn't want to do a slow rollout. We learned in the POC that it was a pretty straightforward tool, and we'd get the most value by just putting it everywhere. And breaking pre-prod can cause pain to other engineering teams, but not really any financial loss to the company, so we are okay with the risks of just putting it everywhere. This really fits with our culture of trust, and we trusted other engineers to communicate and use the tool responsibly. So this took us from like 0 to 2,000 clients in a week, and it was ready to use. We also added LDAP authentication, and we gave all engineers access. Again, we just wanted this to be in everyone's hands. This was all managed under one team. That means that all engineers could run attacks on all services, which is what we wanted again. We didn't want these overly tight permissions or to be overly cautious. We didn't want to maintain multiple teams with different access levels for pre-production. We felt we'd get the best results by making the tool open, accessible, and just encouraging everyone to experiment and accepting the risks that come with that. Trusted our engineers to make smart decisions and to communicate with other teams if they're going to be breaking something. And in order to integrate this into our existing workflows, we created a custom Spinnaker pipeline for triggering chaos attacks. Spinnaker is the tool that our engineers already use for deployments and rollbacks and ramping up their services. And as I mentioned earlier, we felt that by integrating the chaos tooling into existing workflows, we would really increase adoption. And something we discovered early on is that since we're running this tool in pre-prod, most attacks would need a load test going in order to simulate prod traffic. An attack is way more useful when you see the results under a normal load with real traffic, or as close as we can get to real traffic. So this pipeline gave developers an easy way to trigger both an attack and a load test at the same time using the same UI that they're already familiar with and that they use for managing their deployments and other infrastructure tasks. This is the vending machine that, like my earlier analogy, they just press a button and they get chaos. So like most things, rolling out Gremlin on a technical level wasn't really the hard part, but getting users to use it was. So here are the ways we evangelize the tool and tried to educate engineers on how to use it properly. First is a saying I really like, feed the hungry, meaning work with the people who are most interested in the tool first. Drive early adoption, get it in the hands of people who actually want to use it and don't need much convincing. These tend to be your power users. You're going to get good feedback out of them. So that's what we did first, promote it to the teams that we knew would be excited to use it right away. You have to promote the tools often as well. Every post-mortem, every design meeting, etc. You want to be the annoying chaos engineering salesperson, planting the seeds in people's heads that maybe these chaos tools could help them. Keep chaos in the conversation and look for opportunities to promote it as a helpful tool. Documenting use cases was a good idea for us. It gives people an idea of how to use the tool. Mix in your use cases with the technical documentation and help plant those seeds on how engineers can leverage the tool. Identify a few big use cases at your organization, put it in the internal documentation. Hold lots of different learning sessions, demo the tool, talk about chaos engineering philosophy, take Q&A. Again, you're trying to be that chaos engineering salesperson. Sell chaos. If you find a question being asked more than once, document it. The idea is that you want to build up the knowledge base throughout the organization so that everyone's on the same page, not just one special chaos engineering team. Ideally, you get to the point where developers get most of the help they need from their direct teammates and from the documentation, and they just use the tool without ever having to engage an SRE team. While doing this, keep emphasizing experimentation. It's a really important part of chaos engineering. Teach everyone to approach it with the scientific method. Set a hypothesis, run your experiments, report results, adjust the experiment, and repeat. And lastly, I offered my time and helped designing attacks and working through use cases. Self-service as an SRE doesn't mean ignoring development teams. I'm there to help and promote good practices. I would push back on actually running any attacks. In order to use the tool, the other teams need to actually use it. During this whole process, keep in mind that the goal is to empower engineers. You want them to feel confident using the tool and causing chaos. So has self-service chaos engineering actually helped us? We're still fairly early in our chaos engineering journey. I don't have any good data on if it's helped us reach our SLOs or reduced reported problems, though I'd like to get that data as we continue along. But here's some good examples of problems engineers have caught before going to production thanks to Gremlin and chaos engineering practices. Most of these issues weren't really what we were looking for at the time, but happened to uncover, in the process of experimenting with the tools. The first issue that I remember finding was I was actually just messing around with some features and set the system clock back on a few hosts. A little while later, I saw some chatter about people being confused related to the hosts I had targeted. It turns out that when I set the system clock back, some new certificates we had implemented had weird issues. We would have ran into this in production with daylight savings time, but we were able to patch it long before that became a real issue, thanks to just experimenting with different failure scenarios. Another issue that we encountered was some weird timeouts in a dependency. One team kept hitting these timeouts. They were unable to find out really where it was and was having a hard time replicating it. So by adding latency type chaos attacks, we could target those impacted systems. The engineering team was able to track down where the timeout actually was, and they were able to implement better backoffs in the code as well as custom metrics to catch it, and then validate that it all worked by again running those same chaos tests. Another issue that engineering teams uncovered that I thought was a really interesting problem was a problem with how our Elasticsearch recovered from a network outage. We were seeing real problems in production where a network blip or outage would cause significant load on Elasticsearch. By using the chaos tools to black hole traffic to the Elasticsearch host, we were able to see that based on how requests queued up, when the network problems ended, queued requests would flood Elasticsearch and cause the load problems. This wasn't really the issue we were expecting to see. And at first, everyone was confused why we only saw the problems after the issues had been resolved or after the chaos attack ended. But with the chaos toolkit, we were able to really iterate on this problem, experiment, and get a full picture of what was happening and then fix it. And then again, use the tools to validate that the fix worked. And lastly, it gives us an increased confidence in our platform. This is much harder to quantify, but a lot of teams just use the tool to validate their custom metrics, test their SLOs, test failover procedures. They're not trying to debug a problem. They're just making sure everything works as expected, which leads to an increased confidence. And this increased confidence makes the development teams more confident in supporting their own services, and it helps build this knowledge base and trust that comes with the self-service culture that we're really striving for. So now that it's fully rolled out in pre-prod and developers are enabled and encouraged to experiment, what comes next for us? First, we want to just continue to drive adoption. While everyone is enabled to use it, it doesn't mean everyone is. This is where I continue to just be a chaos engineering salesperson and evangelize the tools and drive adoption and figure out what roadblocks there are to developers not using the tool right now. We want to get this more tightly integrated into our continuous integration and deployment tests. If a team can automatically trigger attacks from their tests, they can leverage them to help validate that releases are safe and run infrastructure level tests with their code tests before deployments without really any additional mental load or friction. I also envision putting Gremlin on production hosts as well and causing some real production chaos. We've learned that we get the best results when traffic is closest to prod, and so we'd increase our value a lot by running it against real prod traffic. There would, of course, need to be some more roadblocks and guardrails than we currently have in pre-prod, but we'd really aim for that self-service implementation, putting the power in each engineering team's hands. We would probably break away from our one team model here so that we can section off permissions to individual service owners, though. We also want to start running game days and larger scale attacks. Since individual teams run their chaos attacks right now, they tend to be isolated to specific services. Running game days every once in a while would let us target the whole infrastructure and bring multiple teams together, which would unlock another level of value from all of this and give us a better understanding of our infrastructure as a whole. And lastly, another thing we want to do is start implementing more random chaos. Things like setting up an attack to kill nodes throughout the day, like the classic chaos monkey, or other things to mimic real-world infrastructure failures that is not always planned. Planned experimentation is great, but there's a whole nother level of value from unplanned chaos and real chaos. So that's my talk about fitting chaos engineering into a self-service culture. Thank you all for listening.
One of the last points that you made was about production traffic. And so one of the questions that had come in was regards to, in your pipeline, you mentioned having load tests to simulate traffic. So one of the questions was, what tools do you use to actually generate that load?
Yeah, we use Gatling for running a lot of these type load tests. And each service team, as part of just a healthy service, is expected to write a load test for their services. We also deploy a simulator with every service that mocks out some endpoints for consumers to use to make sure they get like a stable, healthy version of the service in pre-production. So it's just an expectation for all of our developers to have load tests. And within the pipeline itself, we're just kicking off a Jenkins job that then triggers those load tests to run against the targeted version.
Cool. And with those load tests, are you simulating just like average traffic, or do you also simulate like peaks for planning for spikes?
Yeah, that's a parameter they get to pass in. The defaults would just be like normal load throughout the day to make sure it works, but they can pass in different parameters for how many users they want to simulate or what level of load they're looking to get. And so it's really up to the engineering team running it at what level they want to run their load tests.
Okay, cool. So that just falls right in line with that whole self-service idea, right?
Yeah. We really just want them to be able to do it all and give them the amount of control that they need to do it.
So some of the other questions are generally more about that self-service model. You'd mentioned that developers have access to everything. So there was a question of like, are there really any boundaries around this, or how do you how are engineers expected to conduct experiments with respect to other teams?
Sure. So they have access to everything within like the chaos engineering toolkit perspective. They don't have like full SSH to all of pre-prod. They don't have like full root and admin to everything. And that's where like the guardrails that SRE builds comes in. Expectations to them is just communicate if you're going to be breaking something, understand what your services impact, understand what an attack is going to impact, and know the right places to communicate them if you're going to be doing something. It's not been a problem yet. Like every once in a while I'll see them communicate something in a Slack channel, but for the most part, they tend to know what they own and they talk to service owners and they are responsible with the tools.
Cool. So I guess similar to that is, do they ever really test for things like noisy neighbor issues? Because it sounds like all the teams are using this shared infrastructure, and that could be a problem. And if so, how do engineers account for that?
I haven't seen it come up much, but we're currently in the process of moving most of our services to Kubernetes, and I think that'll become a much larger issue with the noisy neighbor. And we're working out how that's going to look. The way we're going to divide out the services is they're owned by different business verticals. And so they just would communicate within those specific verticals, I think is the plan there. But we do see that like becoming a larger issue move to Kubernetes and shared hosts.
Yeah. So I'm curious, with the move to Kubernetes, how is chaos engineering a part of that transition? Are you using it in the migration?
We're setting it up right now, and it will be in place before we start migrating any real services. And the goal is, one, to use it to actually harden the clusters themselves, since running, resource type attacks is going to impact an entire cluster and host. And then the individual teams, we plan on working it into what the migration plan looks like, so that they are running chaos tests as they migrate over to understand the differences between how their services work in the current single tenancy, one service per one host type world versus a shared host Kubernetes world.
Cool. Awesome. Well, it's been fantastic to chat. For everybody else, if you want to continue chatting with Doug, he'll be available in the QA-Doug Cambell channel in Slack. So thanks again, Doug, for your talk. That was fantastic. As mentioned, I do want to shout out to Grubhub because they are fueling part of this conference as we are on air and don't have time to cook for ourselves. So we're definitely making use of your services. So thanks again for joining us.
Yeah, thank you so much.